My name is Benjamin Shanti, and I attend school at Olympic High School. So last summer, I worked with the NC Clean Energy Program, partnered with Livingston and Haven, and Livingston and Haven was the on-site host. So I worked with Livingston and Haven on 3 projects. Our main project was trying to develop a solar streetlight prototype. So they were already selling a similar product, so it's a regular streetlight, but instead of being powered by an off-site grid, so being wired in from the bottom and then feeding into an actual light, the light is actually self-powered. So it all houses everything. So there's a housing, and then on top is your solar panel, and then the light sits on is secured in the bottom. And so the solar panel is charging a battery, and that battery feeds into the light itself. So you're making your own power and being able to make a street light that's actually self-sufficient. It's everything in-house. We were working on making a 3D model using Inventor 2020, which is a 3D CAD software. And then we were also trying to manage some of the logistics, like what goes into their So they're selling a product through Sresky. That's a solar streetlight company within China. They manufacture within China, and we're trying to get away from that. We're trying to see, instead of buying a product from somewhere else, we're a distributor, so where can we buy these products and actually assemble our own product? Not make any of the parts per se, but actually assemble using multiple parts to make our own product to sell. Either assemble in the States or assemble in Tanzania, whichever was feasibly going to be a better model for us. We cover some of the 3D software, making smaller projects. A lot of what we do is there's a class called computer-aided design, and we're able to make a compression fit container using similar software. So you get to learn the softwares in class, and then we were able to use them here. So a lot of it was like learning about the different technologies. So we learned a lot about solar and how we can use these different technologies. We can show how they're used in emerging markets, and show how we don't need to rely on existing infrastructure, but make our own infrastructure that's self-sufficient and that's small scale, that we can prove within these other countries that we can bring back to the States, because a lot of this is investing in an idea. And for people to show the feasibility, for some people, they need to see it actually working. And so it helps us bring it back to the States and use it within these emerging countries as well. So a lot of this is getting away from processes such as fracking or other somewhat harmful activities like we have with these oil spills. When we're trying to move these natural resources from place to place, a lot of human error or even machinery error can occur, and so then we have these catastrophic natural disasters that we hear about in the news and that get highly publicized. We have these issues that are killing entire ecosystems, where we can cut all this out. We can use direct sources that we have in our day-to-day life, such as solar, wind, and hydroelectric. Well, a lot of it's about creativity, like seeing things without them actually physically being there. That's a lot of what an engineer does. They're not the one they're the one designing it and trying to have the ideas and bringing their ideas into reality. A lot of this is forethought, like how am I going to make something work without it actually being in front of me, and understanding the different technologies that go into that. Well, a lot of it is understanding where employees are at the table. So a lot of this is understanding how to build on your own career and what makes you more valuable going into the workforce. And by getting into these internships earlier, you're getting work experience earlier, you're getting the skills you need early on, showing that for an employer, this is an investment. You are an investment for an employer. An employee, you might just be, if you're going into higher level education, if you don't have these internships or work experience, they know that you have the degree. They're looking for 2 things. They're working for your degree, and they're looking for you to actually have experience in the field. If you don't have any of that experience, they're making an unsafe investment. If you already have that work experience early on and you have the education, they're more likely to invest in you because you're making it a safer option for them, and they're more likely to see you as a better working employee. You always have to keep your doors open. Shutting yourself off to younger students, you got to see where the creativity starts. Once something starts, it doesn't always finish. If you cut the line too early, then they're not going to walk through the door. But if you keep them engaged, maybe with paid internship opportunities, a lot of the time to get students into the door, you have to give them these economic benefits. Because a lot of people, when they see a job, they want they want an economic benefit for them, because a lot of them are either supporting their family, supporting themselves, or supporting further education. They want to be able to find a way to pay for college. By giving them these economic opportunities, you're giving them, you're starting to lure them in. You're reeling in the fish, and then showing them what you're able to provide for them. When you're showing them if they have different opportunities, then once you get past the economic hurdle, then you've gotten which one would I prefer? Which one do I want to go into? What field do I want to explore? A lot of this stuff scales, so when you see the basic technologies, like we have access to these basic technologies in the classroom, we're actually working with pneumatical systems and hydraulic systems within class, and seeing how simple these little cylinders are, gas cylinders that they're filling up with air pressure, they're doing a small movement, but seeing how that we build into mining operations, or seeing how one solar panel for one little solar street light can turn into a whole street, or a whole solar farm can power a whole community. You got to see how these technologies are building upon themselves. You're starting from the bottom and you're building a building, and you got to see where your foundation starts, and once you figure out your foundation, then you can build the rest of the building. With solar, I learned a lot this summer we were researching online, and then we were also have access to these technologies, because we're taking this existing product apart piece by piece and seeing what it uses, what could be cut out. But a lot of it's fairly essential. You're going to need a battery, and then for a lot of these, Tanzania is a great test market, because you have perfect climate conditions. You get 12 hours of sunlight from 6 a.m. to 6 p.m. and then after 6 p.m. you're dark from 6 p.m. to 6 a.m. So you have this perfect solar condition, because you're right next to the equator, so the sun's hitting it, so you can charge for 12 hours, and then you can disperse energy for 12 hours. So a lot of it goes into being able to understand what other technologies go into this. So how do we build upon this? We have a control board which allows us to do different programmable settings, so we're able to light it for, say, 5 hours at 100% of whatever the capability of that lighting system is. Then for another 5 hours, it goes into a motion mode. So it uses IR. So say in your TV remote, when it connects to your TV, it has it sends an infrared signal. So it's that same technology. We're using infrared to see so when it sees someone walk by, it gets a heat signature from a person, and then it's able to turn the light up. So it goes from 30% to 100% lighting. And then for another 2 hours, it would go to like 70% lighting. So understanding that there's not only feasible electrical technologies, but there's also computers. So there's a lot of different people that go into just making one product. It's not always just one department doing one thing. It's everyone goes into making a product actually come to life. So I think it makes a lot of things open for me for what I might want to do as a career, less in the classroom and more maybe what I want to do in college, or what I might be looking for in another internship partner. So I either want to pursue electrical or mechanical engineering, to either work furthermore with systems such as pneumatics and hydraulics, or aeronautical, or I'd be going into maybe electrical with maybe solar, wind power, other electrical systems, like understanding how these DC microgrids and AC systems work, and how we can actually set up a business with construction. Well, a lot of it's about having free income. So once I get to that point, maybe, but a lot of it is building your own career, and then once you use your own career to jump, as a launch point for you to make your own career, make your own business and your own future. But a lot of it's giving back. So it's a two-way relationship with you and a business. You're getting capital, and you're providing them a service. So once you have enough capital to start your own business, it is a very and thriving opportunity. Well, if they have the passion, it's good to drive your passion, because it's good to have something that you can put yourself into that's actually going to do something. A lot of it's understanding like what you like already, and being able to do that within a job or an opportunity, and learning more about what you can actually do to make things better and more functional for a company that's looking into this, or your own excursion with your own company. Okay, so I started off when I got to Olympic. Before I got to Olympic, my middle school had a few different programs. I we did a biomedical stuff, so I got to learn a little bit more about the body. But what I really explored we have these free periods where we can go explore. We'll have like little mini clubs, like they had chess you could go do. But one of them was called TSA, and that's called the Technology Student Association. It's not related to the airports. So with TSA, you actually get to do different projects and learn about different things. So I was on we did this project called it was a mechanical engineering event, and you actually got to build a Rubens Goldberg machine. So I started out doing that in 8th grade, and then I went on in 9th grade. I did an intro to engineering class where I got to learn about engineering design. So we did 3D sketching and 2D design sketching. So learning about how before you get to using the computers and using these softwares, understanding what goes into using these softwares. So you're doing what's on the computer, but you're doing it by hand. So you're understanding how to sketch something out. So then when you take it over to the computer, you have a basic idea of what you've already done on paper, what you can actually do and put into a computer. And then from there, I went on. Last year, I tried one of the other career and technical education pathways with the business pathway, learning about some key terminology and just some early stuff, but it was a little, I wasn't as enthralled as I have been with engineering, so I then went on to try out the computer integrated manufacturing class because that was another step in the pathway, and I got to learn about making small containers, and we worked with little Vex robots, the people that make the hex bugs. We got to learn about how to make a small project and make it go, do a little race, see who gets through a line the fastest using AR and color sensing technology. So it would follow which line would you want it to follow. It had 3 lines. It had a yellow, a green, and a red. And you were trying to make it go through the path, but the lines would, so it's curving, so you got to make sure you use the right color to make it turn the right direction. And then afterwards, I did this internship this summer. And then we've also, this school year, we were making these lanterns. So we have a shop, it's called a ShopBot, and it's basically, you could do a 2D CAD drawing. You can take that 2D CAD drawing, and then once you have that 2D CAD drawing, you take it into a VCarve software, which is what the machine uses to cut out the software. And then you're cutting out, you basically friction fit the multiple pieces. So you can turn 2D shapes. So you have one side, one trapezoid, and you're connecting each trapezoid together to make a full lantern. And we were making holiday lanterns. You just gotta look more for the opportunities. Listen to what some of your teachers might be saying, or listen to what you've seen online. Like a lot of this stuff I've heard about before. A lot of this like emerging technologies you hear about through social media and other sources, and you gotta maybe don't let it get cut too short. Kind of try to follow the lead and see where it goes. I just enjoy it. I think the projects we get into and the projects we're able to do at the school are more interesting, and I get to learn more and more. And it's just a good way to, instead of having free time, I get to actually do something that can further my interest and my knowledge in these fields. I mean, you gotta see what your school is offering, because different schools offer different things. And Olympic has a really good opportunity with our engineering facility, and we have this building that we have multiple business partners. It's a $400,000 space with CNC manufacturing machines. So machines where you can take a piece of material and you design on computers, and you can form it into whatever you can imagine. Or we can cut out these different 2D pieces and form fit them into a 3D shape. And a lot of it's just being able to use your creativity or using your imagination to actually bring things into reality, and understanding that maybe we don't just cut this idea, but maybe we keep building and building and see where it goes. So a lot of the time with these different projects we're doing, so you get to be able to design something and actually make it in reality. With the lanterns and with the different projects, we're able to design them beforehand and actually understand how we're going to make a product step by step. And a lot of this is project based. So instead of getting graded on a test or something, we're actually, instead of using it for one application, we're using it to fill these multiple applications. We're designing, we're creating, and we're finalizing a product that we could potentially sell at the school, maybe as a fundraiser, or different ways that we can get the school money so we can build and do more projects. We work with MSSC on the manufacturing, but that's about it. I mean, tests only get you so far. Once you have the certification, it's about using it in application. So a lot of the certifications is building on and learning how to use it in an application, so then we can understand more about the knowledge that we need to take a test.